Welcome once again everyone. በሌላ ፕሮብለም አሁንም ተመልሻለሁ። እዚህ ፕሮብለም የምናየው ደግሞ ኮንዘርቬሽን ኦፍ ሞመንተም ኤንድ ኤነርጂ ጋር ተመሳሳይ ነው ከፕሪቪየስ ፕሮብለሞች ጋር የተወሰነ ተመሳሳይነት አለው። So let me read the problem and let's do it together. So here we have the two objects of mass m1 1 kilogram and m2 2 kilogram are placed on horizontal frictionless surfaces, and a compressed spring force constant K 100 Newton per meter is placed between them. Neglect the mass of the spring. The spring is not attached to either object and is compressed a distance of 10 centimeter. If objects are released from rest, find the final velocity of each object. So ከዚህ ይሄ ፕሮብለም ዲማንድ የሚያደርገን የሚጠይቀን ሂር መጀመሪያ ላይ ሁለት ብሎክ አለን፣ ብሎክ 1 እና ብሎክ 2። እነዚህ ብሎኮች spring with certain spring, they are attached by the spring, but there's no, of course, any very physical attachment between the spring and the block, but there are any moment where they compress the spring by some distance. That's the amount of x amount of length ከስፕሪንጉ ጋር compressed ተደርጎ ሁለቱ ማሶች attached የሆኑ ናቸው። So the compressed length here x is in fact 10 centimeter. Of course, here from our given information here, the mass of block 1 is 1 kg, and the mass of block 2 is 2 kg. And other constant we have given is the spring constant, in which two blocks are attached together by 100 Newton per meter. Now, ከነዚህ given information ተነስተን ምንድነው ዲማንድ የሚያደርገው? now ሪሊስ የሆን ሁለቱ ብሎኮች 10 ሴንቲሜትር ኮምፕረስድ አድርገው ስፕሪንጉን at a moment of release they will move in opposite direction. So when they move in this direction and the one moves to the left, then they will have, of course, a kinetic energy. So the problem ላይ apply የምናደርገው ሁለት ኮንሰፕት ነው፣ conservation of energy and conservation of linear momentum. Primarily ግን conservation of energy ስንጠቀም ፕሮብለማችንን በቀላሉ መስራት እንችላለን። So ከዚህ እንደምንመለከተው now ብሎኩ compressed እንደሆነ ሲስተማችን here let me go እዚህ ጋር የምናየው ሲስተም ይሄ ሲስተማችን will have the stored potential energy. So the initial energy, or simply the stored energy due to the compression of the spring, is maximum potential energy. So the potential energy of the spring, the mass spring system, would be the half times the spring constant times the compressed length squared. So this will give us, of course, the total energy, because initially we don't have a velocity or simply a movement of a block, so it only have potential energy. In that case, the potential energy would be then simply with direct substitution 100 Newton, or let's just forget calculating. Now here we have a potential energy. This is before the blocks are released. So when the blocks are after released, they will have a kinetic energy in both directions, so both blocks. So the kinetic energy of the blocks is simply the sum of the kinetic energy of individual blocks, half of m1 times v1 squared plus half of m2 v2 squared. Now this is just after this is before, now this is after release. So we know that from conservation of energy conservation of energy. So the potential energy, initially the potential energy equivalent to the kinetic energy of the system after release. That being said, the potential energy is equivalent to the kinetic energy. So here by direct substitution we will find that half of k x squared equals half of m1 v1 squared plus half of m2 v2 squared. Now we have found here one relation. ከዚህ relation let's say equation 1. Now next የምንጠቀመው idea ብንኖር after blocks are released, of course the momentum of the system is conserved. From conservation of momentum, okay, momentum before release is equivalent to the momentum after release. So the momentum before the release, two blocks are they have not any momentum, so the momentum of each blocks would be 0. So this is the 0. So the final momentum of after two blocks are released, they will have their own momentum, one to the right, one to the left. So here the final momentum or after momentum will be m1 times v1 plus m2 times v2. From here, by simplification, we will get that v2 is minus m1 divided by m2 times v1. Here kazi we get one relation. Let's take this is equation 2. Now ሁለቱ ኢኩዌሽኖችን ኮምባይን በማድረግ ለእያንዳንዱ የቬሎሲቲ ቫልዩ ሶልቭ ማድረግ it will be simple. Now simple with direct substitution, v2 for here, we make a direct substitution over here, and then it would be easy to find the velocity of each blocks after collision, after moment of release. So here half kx squared equivalent to half of m1 v1 squared plus half of m2. Here with direct substitution you would get minus m1 over m2. This is the times v1 squared. Now what we get here, we don't need any half term in this guy, and all given information are right there. We know the spring constant, we know the maximum spring compressed length. Then just by putting all the value, you would get that 100 Newton per meter times the compressed length is 0.1 meter. That's 10 centimeter. You should be expressed in terms of meter. This should equivalent to m1 is here from our given formation 1 kilogram, m2 is 2 kilogram. Alright, so m1 is 1 kilogram times v1 squared, and here of course plus m2 is 2 kilogram times minus 1 kilogram divided by 2 kilogram times v1 squared. Okay, and this implies you would get with direct simplification the v1 is approximately 0.82 meter per second. And finally, if you found velocity of block 1, then it will be simple to find the velocity of block 2 before in equation ሁለተኛው equation ላይ ምን ብለናል? v2 is minus m1 over m2 times v1. So v2 would be minus m1 over m2 times v1. In fact, mass 1 is 1 kilogram, mass 2 is 2 kilograms, so v2 is approximately or let's say just equals 0.41 meter per second. So block 2 moves to the right, block 1 moves to the left. So they will move in opposite direction. So this gives you, of course, what in this expression, the desired result, the velocity of each blocks. I hope more supplementary የሆነ ፕሮብለም ቢያዘጋጁት ነው። ከዚህ የሆነ ኮንሰፕት እንዳገኛችሁ ተስፋ አደርጋለሁ። So see you on the next video. I'll see you next time.